Okay, here's a question from the GCSE paper, AQA board, June 2008. It's from the back of the paper, so it's one of the most challenging. And here's the question. The diagram shows the circle x squared plus y squared equals 26, and the line y equals x plus 4. The line in the circle intersect at points A and B. Show that the x coordinates of A and B satisfy this equation. So I find it very helpful to draw things out, and so that's what I'm going to do now. So I'll just pop this over there and copy the diagram. So we'll put in Cartesian axes, x and y. We'll do our best circle, and we'll put a line in there. This is the point A, point B. There's the origin. Let's think about this. Let's just think about, let's take that out and let's put in just the circle. So here's the axes. Ugh, dreadful. There's a circle. Pick any point on the circle and consider a radius out to that circle, and we can see that the coordinates of that point, let's call that x and let's call that y. This is a right angled triangle, and this is the hypotenuse of that right angled triangle, and we can say then, using Pythagoras, that the square on the hypotenuse is equal to the sum of the squares on the other two sides. Well, the length of that side is just, if that's the origin, is from 0 to x is just x, so the length of that side is x. So Pythagoras says h squared equals x squared, and by a similar process on the other side, y squared. That's going to be the case. Now in this question, we're told that h squared is equal to 26, which means, by the way, that h is equal to 5.1, being the square root of 26. So far so good, and we can see that wherever you put this radius, any point on this circle, this will still be true. There'll be an x coordinate and a y coordinate, and it will be true that the sum of the squares of the x and the y coordinate will equal to 26. So there's the circle going round. So now back to the main problem at hand, and we'll pop the original diagram back on. There's the circle, there's the point B and the point A. This is the line y equals x plus 4, and this is the line x squared plus y squared squared equals 26. By the way, we should recognize from y equals mx plus c, m here is 1, the slope of this line is 1, and the y-intercept is 4. That might be useful for us, but it might not be useful for us. The key insight here is that we're being asked to show that the x coordinates of A and B satisfy that equation, and the equation that they said was that, so at A and B, it is true that x squared plus 4x minus 5 equals 0. So so the insight is that at point A and point B, both of these equations are true. That the lines of an equation are all of the points where that equation is true. So when those lines cross, it means that this is true, y equals x plus 4, and this is true, x squared plus y squared equals 26. Well, so we have two simultaneous equations. They're simultaneously true at this point and at this point. So let's just focus on point A, and we can say, we can just substitute for y in this equation. So we start with x squared plus y squared is equal to 26, and we can rapidly change that to x squared plus, and instead of y we put x plus 4, which is the value of y at that point squared equals 26. Okay, well, if we rearrange this, we can see that x squared equals 26 minus x plus 4 whole squared, which is equal to 26 minus this stuff. This is x plus 4, which is just what the meaning of x plus 4 squared is. So that's 26 minus x squared. It's going to come out into 8x plus 16 if you just do your crab claw thing there. Now we need to be a little bit careful when we're subtracting from a number a bunch of stuff in brackets. So we've got the 26, and we're going to be taking away this x squared, and we're going to be taking away 8x, and we're going to be taking away 16. So these signs have flipped because we're taking everything away from 26. Well, we can rearrange this to say that this is what x squared is, so if we add an x squared and an 8x to both sides, then these will disappear from this side and reappear over here. So we'll have x squared plus x squared is 2x squared plus 8x is equal to 26 minus 16, which is of course 10. 26 minus 16 is 10. So we can put this in standard form. 2x squared plus 8x minus 10 equals 0. Standard form being in this order and set to 0, so we've brought the 10 over here. And if we divide through by 2, all these numbers are even, and this coefficient, the number we're multiplying x squared by, is not 1, and we'd like it to be because it makes solving things much easier. We can have that x squared plus half of 8 is 4x, minus half of 10 is 5, equals 0. That is, of course, what we're being asked to prove. So that's the answer to part A. So far, so good. Now, the next thing that we've been asked to prove is, hence find the coordinates of A and B. So let's look at A and B. So this equation has a couple of solutions. It's easily factorized. We need two numbers which multiply to make minus 5 and add to make 4, and those two numbers are 5 and minus 1. So this whole thing factorizes to be x plus 5, x minus 1 equals 0. If you don't believe me, pause the video, multiply these out, and you'll end up back where you started. So this is the correct factorization of this. And this has two solutions, where when either this is 0 or this is 0, because 0 times something is nothing, and something times 0 is also nothing. So when either one of these is 0, we have a solution. And so the solutions are, well, if x is equal to 1, then 1 minus 1 is 0, so that's one solution. And if x is equal to minus 5, that's another solution. So those are the two solutions for this equation, when x is 1 and x is minus 5. Now, we can immediately then go back to this diagram and say, aha, at this point on the diagram, the x coordinate is 1. And at this point on the diagram, I'll move it to the side a little bit, the x coordinate is minus 5. Now we can just use Pythagoras to work out what the y coordinates are. So we put the hypotenuse on. The hypotenuse is always the same because this is the radius of a circle, and the radius of a circle is by definition the same all the way around. So this is going to be 8 squared is going to be 26, and 8 squared is going to be 26. So we've got one triangle here to solve, and one triangle here to solve, and by solve I mean find the y coordinate of each one. So let's take point A. At point A we have that the square on the hypotenuse, we're told that answer is 26, is equal to the sum of the squares on the other two sides. Well, at A the x coordinate is 1, 1 squared is 1, plus y squared. So we have that y squared is equal to 25, and therefore y is equal to 5. So the coordinates at this point are 1, 5. And then at b, the same thing applies. The square on the hypotenuse is equal to the sum of the squares on the other two sides. This time the x coordinate is minus 5. Minus 5 squared is 25. And we still need to add that to y squared. So it follows that y squared is equal to 26 minus 25, which is 1, which means that y is the root of 1, which is just 1. So here, y is 1. So the two answers are that A has the coordinates 1, 5, and that B has the coordinates minus 5. And that's minus 1. So that's the magnitude is 1, but we're going downwards, so this is minus 1. And that's the answer.